Hello, Honors Trade Pre-Calc. We are taking some notes on the rest of 4.3. So we're going to first mention what we know a circle to be. And circles, if you remember, are the set of points that are equidistant, the same distance, right? Equidistant from a center point. I've got a picture of a circle here. Specifically, if you remember, the equation of a circle is x minus h squared plus y minus k squared is equal to r squared, where h and k are the center of the circle, hk, and r is the length of the radius. So we want to consider a very specific type of circle known as the unit circle that's given by the equation 1 is equal to x squared plus y squared. And this circle is shown at the right. So notice a couple things about this circle. It is centered at the origin. That's why it's x squared plus y squared. There's no h and k. And it has a radius of 1, right? The length of this distance right here is 1. The length of this distance is 1, which is evident by going through the point 1, 0 or 0, 1. This unit circle is super, super important to us. So we're going to come back to it in a moment. If we consider the unit circle, so I'm going to sketch a little circle for you. Oh gosh, hold on. All right, that's a much better circle. So we've got this circle, and again, this is the unit circle right here, which means it has a radius of 1. Or if I draw this little triangle right here, I know that this length, the hypotenuse, is 1 because it's the unit circle, very specifically. I also know that this bottom length is some x distance, and this upper length is some y distance, or like this point, which is some x comma y, is these lengths. This idea is exactly back to this first problem we did, where this is the point 3, 5, so the side lengths of the triangle are 3 and 5. So we know this about our circle, and if I say that this angle in here is angle theta, sorry that it's kind of a small picture, we can find our sine, cosine, tangent ratios of this angle theta using our good old SOHCAHTOA. So sine of this angle theta is equal to opposite, which is y, over the hypotenuse, which is 1. But we probably wouldn't actually say it as y over 1. We would just say it's equal to y. Or cosine of theta is the adjacent x over 1, which is just equal to x. Tangent, which is opposite over adjacent, is y over x. Cosecant is equal to the reciprocal of sine, 1 over y. Secant is the reciprocal of cosine, 1 over x. And cotangent is the reciprocal of tangent, x over y. This really means if I know any point on this circle, specifically that is the unit circle, because it has a radius of 1, I know my cosine value of that angle will be the x coordinate on that circle, or the sine value of that angle will be the y coordinate. Let's talk about one more thing, and then we'll build our unit circle. The last thing we need to remember are our good old triangles, our 30, 60, 90 triangles, and our 45, 45, 90. So if we look at our 45, 45, 90, right, this isosceles triangle here, and I tell you the hypotenuse is 1, we could go through 1 squared is equal to x squared plus x squared. We could solve this. 2x squared is equal to 1. 1 over 2 is equal to x squared. Take the square root of both sides. So square root of 1 over the square root of 2 is equal to x. And of course, if we want to simplify that, make that look nicer, what I have just figured out is that the side length here of each of these legs of this right triangle, 45, 45, 90 triangle, are square root of 2 over 2 and square root of 2 over 2. So this is our 45, 45, 90 triangle. If we look at our 30, 60, 90 triangles, 30, 60, and 30, 60, again, we're going to make our hypotenuse 1 because we are eventually going to take these triangles and add them to our unit circle. So I want my hypotenuse to be 1. Now, if you remember the ratios of our 30, 60, 90 triangles, the short side is half of the hypotenuse, or another way to say that is the hypotenuse is 2 times the short side. So that means my short side in both of these cases is 1/2. And if we remember, the long side is the square root of 3 times the short side, or square root of 3 over 2. Square root of 3 over 2. So all of this information is kind of way back in first semester. We looked at these special right triangles, and we're going to need these because we are going to put them over our unit circle. To draw our unit circle, we are going to start from scratch. We're going to do this all in just like one thing. And I would say right now, if you do not have a full piece of paper in front of you, like you are taking notes on the bottom of a page, I would turn the page in your notebook. You will want a full page for this. This will take up a lot of space. We're going to start by making our XY coordinate plane, and I'm going to draw a circle. That was not very good, but hopefully you'll forgive me. The first thing I want to look at is labeling all of our angles and degrees in both degrees and radians. So if I don't move, right, I have gone 0 degrees or 0 radians. If I travel half of the circle, so technically this distance, I have gone either 180 degrees or pi radians. That's where we are going to start. We are going to start by considering the top half of our circle, and I'm going to begin by cutting this top half into 6 equal pieces. In order to cut something into 6 equal parts, I think it's probably easiest to start by considering cutting it in half, right? So we have 2 equal pieces, and then each of those in thirds. Now, yours doesn't need to be perfect, but do your best so that each of these pieces is equal. So notice, if I count, I have 1, 2, 3, 4, 5, 6 equal pieces of this half of a circle. If I have 6 equal pieces, and I know that the angle of the entire thing is 180 degrees, 6 equal pieces, 180 degrees, each of these is technically 30 degrees, which means this first angle, oops, I want that in red. This first angle here would be at 30 degrees, this angle measure. Then I jump up to 60 degrees, right, adding 30. We are at 90 degrees, 120 degrees, and 150 degrees. The degrees is relatively not easy, but it's a lot more concrete to think about. Why don't we continue to the bottom half of our circle? And again, I'm going to suggest cutting it into 6 equal pieces right off the bat. So cutting this in thirds and this side in thirds again. So if we're at 180, when we go to here, travel another 30, and we would be at 210 degrees. Then add another 30, 240. All the way down here is 270 degrees. Then we're at 300, 330 degrees, or a full circle, we know to be 360 degrees. Pat yourselves on the back. You just got through the first part of our unit circle. But of course, we also want to consider what these would be in radians. Now remember, a half of a circle is pi radians. And we just cut the top half of our circle into 6 equal pieces. So this first angle, 30 degrees, is also pi over 6 radians, 1/6 of the half of a circle. So then this next one would be, well, this is 1/6. This is technically 2 pi over 6. Now, we're smarter than that. Instead of 2 pi over 6, we could write this as pi over 3. So 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, and then 6 pi over 6, which would just be pi. Then we continue. So this is 6 over 6. This would be 7 pi over 6, 8 pi over 6, which I would simplify to 4 pi over 3. So this is, where are we at? 6, 7, 8. This is 9 pi over 6, or 3 pi over 2. This would be 10 pi over 6, or 5 pi over 3. 10, this is 11 pi over 6. And then we are at 12 pi over 6, which of course we know is 2 pi. I'm going to take a moment and clean this up a little, make it look a little nicer. All right, all I did was take off the pi over 6's that were not simplified. So instead of 1, 2, 3 pi over 6, I'm just left it as pi over 2 because that's the better simplified version. And I just made all my numbers a little smaller. Now, there is one other way we cut up our circle, and it's by cutting it into 4 equal pieces. So for a moment, I am going to set this unit circle's transparency to be a little bit more so we can focus for a second on another piece of this. If I consider, oh man, I'm not going to be able to do this very good. Here's our same circle, right? And I know that this distance is pi. One other way we often cut up our unit circle is into 4 equal pieces. So again, I'm going to cut it in half, and then I'm going to cut each half in half. Notice if you just focus on the blue and you ignore your red lines, and I'm going to even go so far as to make it more transparent for a moment. Again, if we ignore those red lines, look at squint, those blue pieces are equal. So I'm going to keep those in here. And now we're going to add in what these would be. If I am considering this entire unit circle as degrees, right? Half of the circle is 180. A quarter of the circle is 90. Half of that would be 45 degrees. And so that means that this is 45 degrees, this is 45 degrees. We take 90 and we add 45 degrees to get to 135 degrees. Then we're still at pi, or excuse me, 180. Down here, I'm going to cut it into 4 equal pieces as well. And so we have 180 plus 45 is 225 degrees. 225 plus 45 is 270. We already have that one. And 270 plus 45 degrees is 315 degrees. And then we need to do our radians, but this one's not so bad. We cut it into 4 equal parts, right? So this would be 1/4 pi over 4. This guy is 2/4, but we already have it, right? Pi over 2. Right here we have 3 pi over 4, 3/4, and then 4/4. Then we have 5 pi over 4, 5/4, 6 pi over 4, which would be 3 pi over 2. 6 we're at, so this is 7 pi over 4, and then up here would be 8 pi over 4, but of course we don't write it like that. We would write it as 2 pi. All right, I just took a moment to clean it up a bit. Notice we have every single angle drawn here. We have every single angle drawn with both degrees and radians. We are going to stop here for today, and we will continue looking at the unit circle in class on Thursday and Friday. Please, 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 please make sure you have this drawing ready in your notebook because we are going to add to it. If you want to practice drawing it again, by all means do so, and I will talk to you soon.